Hi LHMS, today our lesson is on adding integers and rational numbers. Before we can actually get into this lesson, the first thing that we need to do is we need to define what an integer is versus what a rational number is. Integers are whole numbers and their negatives or opposites. An example might be -3 and 3. Both are whole numbers. -3 is the opposite of 3. Rational numbers actually include integers. Rational numbers include whole numbers, fractions, and decimals, and their opposites. So an example here might be 3/4 and -3/4 are included in rational numbers where they were not in integers. Our first problem today, we are going to start with integers or whole numbers. In the Broncos football game last Saturday, on first down, the Broncos moved backward from the line of scrimmage 7 yards. On second down, they advanced 5 yards back toward the original line of scrimmage. How many yards from the original line of scrimmage are they prior to the snap for third down? So our problem today, if the Broncos moved backward 7 yards, then they are going -7 yards. If on second down they moved forward or advanced 5 yards, we are adding 5 more to that. One way that we can use to solve this is to use counters, and you might have used these before where you actually have chips or blocks or something that you can move around. Now, if you don't have those available to you, another thing that you can do is you can always draw them out, like I've done here. And so I've drawn my -7. You can see we have 7 counters here, and then my +5 counters. So how do we actually complete this problem? So our problem is -7 plus 5. Now, for every negative and positive that we have here, they're going to cancel each other out. So this one, these first ones cancel each other out. The second ones cancel each other out. The third ones cancel each other out. The fourth ones and the fifth ones. Our answer is our remaining counters. Since we've used up all of our positive counters, we know that our answer has to be negative. And in this case, we have 2 counters left. Our answer is -2. Now, to put our answer back into context, we are -2 yards from the line of scrimmage. So by putting it into the sentence, I now have a context for my -2 yards. And I'm truly answering my question of how far they are from the original line of scrimmage at the start of third down. Another method that we can use for solving the same problem is a number line. Now, I've already drawn my number line on my whiteboard so that it's ready to go. When I'm trying to decide how long to draw my number line, I went ahead and I put it out 12 spaces in each direction, because I know if I were to add these two together as if they were both positive, I would need at least 12 spaces. So not knowing exactly where I'm going to end up, I'm trying to give myself plenty of room to work. Now, for this instance, 0 is going to be my line of scrimmage. Okay, and so I'm going to start at 0 and I'm going to move from there. The first move on first down that the Broncos made was they went backward 7 yards. So here's 5, 2 more past 5 is 7. Okay, so here we can show the -7. They went backwards 7 yards from the line of scrimmage. Then on second down, they moved forward from that point 5 yards. Okay, so there's 5 yards forward. We're adding back on the 5 yards that they advanced towards the line of scrimmage on second down. That places our answer right here on this line. That line represents -2. That would look more like a 2. And so once again, we can see that our answer is -2. Another way that you can do this, let me switch colors to show you. You can actually start at the -7 since that is the first number in our expression. And from that -7, just go ahead and add the 5, and you'll find that we end up in the same spot as -2. And once again, since we are trying to put this in context, we say that the Broncos are now -2 yards from the original line of scrimmage. Okay, so trying to put our answer into the context of our question. Now we're ready to use the standard algorithm to solve our problem. Once again, we have -7 for the 7 yards the Broncos moved backwards, and then +5 for the 5 yards that they then move forward. When we are using the standard algorithm to add integers, there are a couple of rules for addition that we can follow. The first rule is if the signs are the same, so either both signs are negative or both signs are positive, add the numbers together and keep the sign. The second rule that we can follow for addition is if the signs are different, subtract the smaller number from the larger number. Keep the sign of the larger number. So in our problem here, we're looking at the -7 is the larger number, so we're going to take 7 minus 5. 7 minus 5 is going to give us an answer of 2. Now I want to go back up to that -7 because our rule says to keep the sign of the larger number. So since our 7 is negative, our answer also has to be negative, and we get an answer of -2. Once again, we want to make sure and put this into context. We're going to write out a sentence. The Broncos are -2 yards from the original line of scrimmage. For our second problem today, we have a very similar problem. The next time the Broncos had the ball on first down, Southwick was sacked 3/4 of a yard behind the line of scrimmage. On second down, he fumbled the snap and dived on the ball 7/8 of a yard further behind the line. How far are the Broncos now from the original line of scrimmage? Now I realize that we don't usually measure yards in fractions when we're talking about a football game, but it worked out well for what we're trying to demonstrate. We are not going to use counters for this example because counters are much harder to use when we are dealing with fractions. For this problem, we are just going to use the number line and the algorithm. This time, our problem is that he was sacked 3/4 of a yard behind the line. So we're going to start off with a -3/4. From there, on second down, he fumbled the snap and he went further 7/8 yard behind the line. So that is also negative. And since we're wanting to know the total yardage behind the original scrimmage line he is now, or the Broncos are now, we're going to add these two numbers together. Now I've already drawn out my number line. Because I know that the Broncos moved backwards both times from my story, I just went ahead and used negative part of the number line. So this is -1 and this is -2. In the first part of our problem, he sacked 3/4 of a yard behind the line. So we can start at the line, which is 0 again. Here's our line of scrimmage. Sorry for the shorthand. There's our line of scrimmage, and we are going to move back 3/4 of a yard. Okay, so that's how far back they moved on first down. Then on second down, they moved another 7/8 further back. Now, right now my line is broken up into fourths, but it's real easy to find that common denominator on the number line by just adding another tick in here for my eighths. I'm going to start at the -3/4 and I want to count back 7/8. 1, 2, 3, 4, 5, 6, 7. Bring my arrow in to show exactly where I'm going. Here is my -7/8. That gives me an answer right here. Now the question is, what is that number? Well, here's 1 and here's 2, so I know that it is between the 1 and the 2. And I know that each of the little dashes now represents 1/8. So I'm going to start counting at -1. So I have -1, -1 and 1/8, 1 and 2/8, 1 and 3/8, 1 and 4/8, 1 and 5/8. So my number sentence ended at -1 and 5/8. Remember when we are working backwards on a number line, like we are here, that the 0, we're counting 0 to 1 and 1 to 2, just like we were if we were going in the other direction. You want to make sure that you're careful not to put the 3/4 in the wrong place. I've seen kids try and put 3/4 right here, which is really 1/4. So just watch out for that mistake. Make sure that you are actually counting in the right direction and counting backwards. Our answer for our problem then is -1 and 5/8 yards. If we put this in context, we can say the Broncos are -1 and 5/8 yards back of the original line of scrimmage. Now let's look at the algorithm for this problem. Once again, we know that the Broncos moved back 3/4 of a yard on first down, and they moved back another 7/8 on second down. So we are adding these two negative numbers together. So first of all, we want to figure out which rule applies to this particular problem. And you'll see that our first rule, that if the signs are the same, add the numbers together and keep the sign, applies. So we can kind of forget about the negatives for a minute, and we're just going to add 3/4 plus 7/8. Before we can do that, we need to find a common denominator for our 3/4. We can multiply both of these numbers by 2 so that we now have a common denominator of 8. That makes our problem 6/8 plus 7/8. Now I can add straight across. 6 plus 7 is going to give me 13/8. Now, since both of my numbers are negative, I'm keeping that sign, and I can go ahead and put it back in here. You can keep it all along if you want, it's not a problem. But if you do want to forget about it for a minute, that's okay too. Just make sure that it does end up back in your answer. Now I'm not quite done yet. Once again, I need to simplify my answer. So I'm going to take 13 divided by 8, knocking my fraction over. 8 goes into 13 one time. We're going to subtract our 8. We have 5 left over. So our answer is 1 5/8. Once again, don't forget that negative sign. To put it in context one last time, the Broncos are -1 5/8 yards behind the original line of scrimmage. Alright, Lake Hazel, that concludes our video on adding integers and rational numbers. A few things to remember from the lesson: the definition of an integer, the definition of a rational number, the 3 methods of adding that we talked about, using counters, using the number line, and using the algorithm. Also make sure that those addition rules are making sense for you. And once again, if you have any questions, make sure that you ask your teacher and get things cleared up. See you next time.